Welcome back to Bombware. Today we're building out a basic level map. The plan here is to make a very simple grid-based level, which means everything will be done in squares, or square-ish. To make life easier, I wanted to create a base unit of measure. I started with a bunch of red boxes, but quickly realized that this strategy was not really going to cut it. Why not? Well, we don't really get a feel for the sizing of the items. We can see how big the boxes are, but there isn't any good frame of reference. Luckily for me, there is reference material I can already use to help me out. I'd like to introduce you to an old friend, the Mario sprite. The Mario sprite is an example of a 16 by 16 pixel sprite. This is incredibly handy for me because I have a feel for how the sprite should look, so it'll be easier to pick out a size. With an extreme amount of apprehension, I've decided to go with a 24 pixel base, with 12 by 12 being the smallest unit of measure. In some way, everything from this point moving forward will fit in these dimensions. I'm really hoping this doesn't come back to bite me. Good news for anybody who's playing at home. I've already encountered an issue using 24 by 24 pixel grids. The old sprites can go down to an 8 by 8 as their smallest denominator. The problem is using a 24 by 24 pixel grid means that 8 only goes into 24 3 times. For every pixel I want to enlarge to make the sprites bigger for the game, means that in this case, I have to do 1.5 pixels to replace that. So, I'm not going to do that. As you can see, I'm already at the top of the head here, and I've already encountered this problem. So for example, if I were to take the foot at the bottom right, each pixel would not be 2, it would actually be 1.5. So at this point I've decided I'm going up to a 32 by 32 pixel grid. Everything's going to be a bit bigger, but I don't think that's going to be a problem. I've got a pretty good amount of real estate on the screen, so I think I'll be able to make it work. Another advantage I like here too is that I'm able to just resize these sprite dimensions. So instead of having to go out there and manually redraw each one, I can just change my sprite size. I have an 80 pixel wide sprite, and that's because that's 16 pixels times 5. For the 5 boxes going across the top. What do? I double the pixel grid. Because I'm multiplying by 2, that means 80 times 2 is 160. Locking my aspect ratio resizes the height for me, and here we are. My sprite has already been resized for me, and I'm ready to roll. With some more sprites on hand, we can goof around with drawing screens. I'm not constantly working with the canvas, so I'm not always going to know the best method. What I do know, however, is that I want to make each step as easy for me as possible. What better way than a function to create the floors, which right now is just going to be a line. Awesome. Because the ground takes up large portions of the screen, I considered using a repeating background. It's a great strategy at first, but causes a weird visual effect. When the image is turned into a repeating pattern, which can be used as a background, it gets locked to the upper left corner of the canvas. Whenever an element that uses that background moves, the image stays in place. It's the same as looking through the window of a car while driving. The window moves while everything else stays in place. This can be resolved by translating the canvas position, then translating it back after drawing the containing element. I went as far as researching some strategies to handle this, but I'm lazy. So for now, each block inside the floor will be drawn individually. Not entirely sure how long we can ride this train, but for now, I'm going to hang on to this website for a while as a reference for how to do this. It's better to have it and not need it than need it and not have it. I didn't attempt any benchmarking to compare, but I'm positive my current strategy is going to be slower. Since I'm not a game developer, I'm more or less stumbling around here. I've done some research before starting, but that doesn't mean I completely understand what I'm doing. I think that's the point of trying something new, though. This does sometimes result in a lot of churn where I spin my wheels without making much progress. Like level building. I started building my level by writing code which would generate it programmatically. This leads to a lot of back and forth between designing levels and programming them. I would not want to do this for multiple levels, because building out this first little map became a huge hassle. I really did not want to go through that whole process for every level I created. Because the entire game is built on a 32 by 32 pixel grid, I can use the same spriting software to map out the level. Not a bad start. Because I'm still using Super Mario Bros. As a reference, using World 1-1 is a logical starting place. By using 2 colors to represent the ground blocks and cubes, I can pretty successfully draw out the map of the level. The base behavior of this strategy is to read each pixel on the level map image. When reading the pixel, I'm provided with the color information in the form of RGBA, or red, green, blue, alpha. The first three being the three primary colors used to represent all the colors we need, and alpha determining the transparency. Any alpha of 1 is completely opaque, and an alpha of 0.5 is half transparent. Each color value is stored anywhere between 0 and 255, giving a total of 256 possible values for each color. By making sure each pixel has a non-overlapping value, I can safely use this pattern without concern. During this iteration, I'm just going to rely on the red value for the blocks. For a while, this felt like it could work out, but that wasn't really the case. Once implemented, I came across a few anomalies, and the render speed got a pretty good kick in the pants. Even when limiting the draw results to be only within the view of the screen, the render process was bogged down. The breakdown here is where I need to read the tile map information, then draw each tile. With the screen set at 1024 by 576, I need to check 32 pixel positions across and 18 pixel positions down. I end up checking 576 pixel values, which really is a super low cost procedure. What is costly is drawing the image 576 times per cycle, and combining the calculations needed to position the image correctly adds up. So much so, the render was costing roughly 6 milliseconds to be performed, which was far from ideal. This initial version would also draw skyblocks, which I took out and received a performance boost. Still, the potential impact when the screen fills up was concerning, which meant it was time to reevaluate. This strategy wasn't a complete waste because the underlying principle behind it is sound. Instead of generating the map each time the render is processed, the map is generated at load time. Once the map is loaded, the map is built onto a virtual canvas, which is then stored. When using the image, I only draw what would be in the viewable area for the player. Granted, the draw is a relatively low-cost operation, but it's worth it to me to save a millisecond or two. Why I like the scheme right now is that it's incredibly easy to add in new elements such as pipes. It took quite a while to get this video done, in part because I kept circling back to the game loop. I just can't leave well enough alone. The other part is life suddenly became a lot more complicated. Fortunately, that's all coming to an end soon, so I'll be able to have more fun with this project. Now that I can build out maps pretty quickly, I think I'm going to play around with a little sprite work. However, whenever I actually plan on working on something, it doesn't pan out. So, until next time.